So we're going to be talking about GPS augmentation systems. GPS is the global positioning system, and it is a way of finding location through information transferred between satellites and receiver stations. Location is determined through measuring the distance between a minimum of 3 satellites and the device being located. The intersection point of these distances is the location of the device. And here's an example picture. So each satellite has their own little sensor area, and they kind of communicate with each other and through a process called triangulation, and they pinpoint the intersection of all their readings, and that is the location. It isn't the most accurate, but that's why we're going through all the augmentation systems to show how different systems provide more accuracy in different uses. So our next one is the ND-GPS, which is the Nationwide Differential GPS. It enhances the normal GPS system by increasing the accuracy of the location point from about 15 centimeters to 10 centimeters, so a 5 centimeter difference. This is due to the addition of ground stations that also measure the distances between the devices, and it compares them with the satellite readings. So here would be kind of an example. There'd be ground towers here that also have their readings of the location, and it would add more accuracy because there's another reading in there. The WAAS, the Wide Area Augmentation System, is a system used by the Federal Aviation Administration, or the FAA, to aid in air navigation for air travel. It uses GPS to track the plane's flight paths so the FAA can regulate air traffic. And here's an example. They just use the satellites to just track the plane's location so they can safely control air traffic. As you can see, it sends off those signals and reads off the plane's location. Also, you can see there's ground towers there too. All right, the CORS is the continuously operating referencing stations, or CORS are stations that measure 3-dimensional locations of devices to further improve accuracy to less than 2 centimeters. It is mainly used for meteorology and weather applications, including tracking space weather. So this would be an example. Just triangulation, but it's using it more on a wider scale and more of a 3D perspective. So you're getting that depth to track the location. Okay, the GDGPS, the Global Differential GPS, is very similar to NDGPS in that it uses ground stations to measure distance to the device, but GDGPS is implicated globally and has a wider range that can span even to space to locate objects, and it's used by NASA. This is just kind of an example of, and it shows kind of the ground tower locations and kind of what they track. It's more international based than just in the national and in the United States area. So it's useful. And last but not least, the IGS, the International GNS, which is the Global Navigation Satellite System Service. So it's kind of a double acronym there. It was made in 1994 to support research around the globe by offering accurate, which is less than 2.5 centimeter positioning through satellite and tracking station measurements. So once again, it's kind of like the GDGPS and NDGPS, where it uses those ground towers to help locate that system. So this is an actual map right now of all the different towers around the United States. And yeah, it just kind of shows you where they are. There's one in Colorado Springs. It's pretty cool. So yeah, that's the presentation. Thank you.